In this activity, students will get the opportunity to make measurements with a thermometer and develop an intuition about the freezing point and boiling point of water. Ensure that you have demonstrated how to read a thermometer and shown students different types of thermometers as outlined in the lesson plan. To begin with, each group of students will need at least one thermometer, or one per student if enough are available, 2 cups, preferably transparent, and access to both ice water and regular cold tap water. You will also need a hot water station consisting of either a freshly boiled kettle or a pot of water on a portable hot plate. Ensure that students only interact with the hot water station one at a time and only under your direct supervision. Once each group has collected some ice water and tap water, instruct them to take it in turns to use their thermometers to measure the temperatures of the water in each cup. Ensuring that the bulb is fully submerged, that they give the thermometer enough time to stabilize, and that their eyes are level with the thermometer when they take their reading. One member of each group should also come up to the hot water station and take a measurement under your supervision. Ensure that the kettle is not turned on while students are interacting with it, as the steam can cause burns. Warning students of the dangers of hot water and steam is also a good opportunity to reinforce the ideas that heat is the jiggling of molecules, and that in hot water and steam, the molecules are moving so fast that they actually have enough energy to damage the molecules in our skin, potentially hurting us. Ask groups to share what values they measured for each of the samples of water. Discuss as a class that the temperature of the ice water is very close to 0 degrees Celsius, which is the freezing point of water, and that the freshly boiled water is very close to 100 degrees Celsius, which is the boiling point of water. Students may find that they each measured slightly different values of temperature for the same samples of water. This is a great opportunity for you to discuss the concept of uncertainty in scientific measurements and some different sources of uncertainty in this activity. Students should then follow this with another quick activity exploring how temperature can change over time. Each group should collect half a cup of cold tap water and half a cup of ice. Ask students to measure the initial temperature of the water. Then, with one student in each group acting as a timekeeper, students should pour the ice into the water and measure the temperature of the water each minute for 5 minutes while lightly stirring with the thermometer. Students should record the temperatures in a table as described in the lesson plan. This might be a good opportunity to introduce students to plotting data on gridded paper if you haven't previously introduced students to making dot plots. Here is an example of a graph you might expect from the activity. Conclude the lesson with a discussion about what temperature represents and how we measure it, some important temperatures to know, and how heat energy moves from warmer water to the cold ice over time due to little packets of energy called phonons being transferred when the molecules of water bump into each other, as outlined in the lesson plan.